You might have come across that jaw-dropping footage where a drone keeps pace with Max Verstappen's Formula One car, flying alongside it for an entire lap at Silverstone. No editing tricks, no special effects, just raw precision and speed, captured in real time. But the real mystery is, how was that even possible? We're talking about following one of the fastest machines on Earth, capable of speeds over 300 kilometers per hour and cornering with razor-sharp precision. Achieving that kind of aerial pursuit wasn't a fluke. It was the result of intense planning, months of technical innovation, and fearless flying. It all started when Red Bull approached the Dutch drone gods in early 2023. The challenge: build a drone fast enough to stick with an F1 car on a full circuit. If you're familiar with racing drones, you know they're fast, but not fast. The best available ones back then topped out around 160 to 180 kilometers per hour and couldn't carry heavy, high-end cameras without losing performance. So the team had to create something entirely new. The main obstacle: speed and acceleration. An F1 car can rocket from 0 to 200 kilometers per hour in under 5 seconds. The drone had to do even better while hauling professional-grade camera gear. Their answer was a purpose-built machine dubbed Drone 1. Everything unnecessary was stripped away. Every component was engineered for speed. The final result: a quadcopter that could blast from 0 to 300 kilometers per hour in around 2 seconds quicker than the F1 car itself. They partnered with university engineers to develop custom motors, each delivering up to 20 kilograms of thrust. That's an insane level of power, far beyond typical FPV racing drones. But going fast isn't enough. At those speeds, the frame has to withstand massive forces without falling apart. The team constructed the drone using a mix of carbon fiber, glass fiber, and 3D printed composites. Strong, lightweight, and able to handle serious G-forces up to 6 gigaseconds in some turns. The complete drone, camera and all, weighed in at under 1 kilogram. That's almost unbelievable for a craft capable of such performance. Then came the issue of power. High speeds mean high energy demands. Traditional drone batteries wouldn't last more than a few minutes, and they needed just enough runtime to survive a full lap, about 2 minutes. So they engineered a custom battery system designed for quick, powerful bursts while staying light and stable. Next up, signal range. Standard drones start to lose connection just a few hundred meters out, especially in environments with interference. But at Silverstone, they needed a signal that could stretch across the track, deliver real-time video, and not lag. Long-range, low-latency video transmitters made that possible, giving the pilot the visual feed needed to fly with split-second precision. Speaking of the pilot, this is where Ralph Hagenberg, aka Shaggy FPV, comes in. There was no GPS, no auto-tracking, just pure human skill. Shaggy had to match every move of the F1 car, every burst of speed, every sudden brake, every high-speed turn, while keeping the drone framed perfectly to capture the shot. It demanded absolute control, muscle memory, and relentless practice. It wasn't just speed that complicated things. When the F1 car hit the straights, it kicked up turbulent or wild, choppy flows that could destabilize the drone. Shaggy had to adjust elevation constantly, staying above that dirty air, then dropping back down for corners to stay close and capture dramatic angles. This took trial after trial. Dozens of prototypes were built, many failed. Some disintegrated midair, others overheated or couldn't handle the forces involved. With each failure came improvements, adjusting the motor output, tweaking the frame design, and even rewriting flight control software to make everything more responsive. They tested their builds relentlessly, chasing race cars, motorbikes, anything fast until they were ready. Finally, on a damp, cloudy day at Silverstone, they got one chance. Max Verstappen drove the RB20, and Shaggy flew the drone. Despite less than ideal weather and low visibility, the flight went off perfectly. For the first time, an FPV drone followed a Formula One car through a full lap, straights, turns, and everything in between. This wasn't luck. It was the result of 8 months of dedicated engineering, precise flying, and pushing boundaries most people wouldn't even think to approach. What they achieved was more than just keeping up. It was cinematic-level footage shot at blistering speeds with a handmade drone and raw human talent. If this kind of next-level tech excites you, stay tuned for more deep dives into how people are pushing the edge of what's possible in drone racing and cinematography.